Alright, this is lesson 3.4 and it is somewhat of a review. It's finding slope and rate of change. And before this lesson we graphed linear equations, and now you're going to go ahead and find the slope of the line and interpret what the slope is as a rate of change. So the first thing we're going to do is we're going to find the slope, and we know that slope is it's of a non-vertical line because the slope of a vertical line is undefined, and it's just the ratio of the rise to the run. So we know it's rise over run. A lot of times I will write that we're looking for the change in y over the change in x, because y controls the y and x controls the run. And this is the Greek letter delta, and it means the change in. Technically, our formula is y2 minus y1 divided by x2 minus x1. This is how we find the change. So now I'm just going to take you through a couple examples. Not too many, because I know that we've done this before. I like to call the first point x1, y1, and the second point x2, y2. Slope has the letter m with it. So if I take y2, I'm going to have negative 1 minus y1, which is 2, over x2, 4, minus x1, 5. So negative 1 minus 2 is negative 3. 4 minus 5 is negative 1. And when I simplify this, I get positive 3 for the slope. Let's look at example 2. I'm going to take 6 minus 3 over 4, subtract negative 2. Be careful, we're actually subtracting the negative 2. So you know that you add the opposite. 6 minus 3 is 3. 4 plus positive 2 now is 6, and that simplifies to a half. Alright, next we have negative 4, negative 2, and 2, negative 2. So my slope works out to be negative 2 subtract negative 2, and 2 subtract negative 4. Again, I will add the opposite in both places here. Negative 2 plus 2 is 0. 2 plus 4 is 6. 0 divided by anything except 0 is 0. So if you recall, a horizontal line has a slope of 0 because there is no rise, it's all run. Next we have negative 3, subtract 4, and 1 subtract 1. Negative 3 subtract 4 is negative 7. 1 subtract 1 is 0. And you cannot divide by 0, it's undefined. And this would be a vertical line. Oh my goodness. I'm having technical issues here. So that's a vertical line. Alright, so we have 4 different types of slopes. We have a positive slope, m is greater than 0. You read a line just like you read a book from left to right. So from left to right, if it looks like we're going up the stairs, then you're going to have a positive slope. If it looks like you're going down the stairs, the slope is less than 0, so it's going to be a negative slope. When you have a horizontal line, there is no rise, so the slope is 0. And if you have a vertical line, then the slope is said to be undefined. So 4 different scenarios. Next, we have the definition of a rate of change. What it does is it compares the change in one quantity to the change in another. For example, if you're paid $60 for working 5 hours, then your hourly wage is $12 an hour. $60 divided by 5 hours is $12 per hour. And it says a rate of change. In this case, it's describing how your pay increases with respect to the time that you work. So the table here shows the cost of using a computer at an internet cafe for a given amount of time. Find the rate of change in cost with respect to time. All we have to do is take two sets of values. I'm looking at the change in cost over the change in time. I'm just going to take these two values. So my cost changes from 14 to 7, and my time changes from 4 to 2. 14 minus 7 is 7. 4 minus 2 is 2. So the rate of change in cost is going to be $3.50 per hour. $3.50. And normally, if it was a linear situation, which this is a line, but if we were just looking for the slope of the line, we'd leave it as 7/2. But you have to look at the context of the problem, and this problem is dealing with cost and time. So $3.50 per hour is what it's changing by. Slope and rate of change. You can interpret the slope of a line as the rate of change. So you can look at the slope, but it is the rate of change. Just like I said back here, if we were to graph this out, you would see that it's a line. There's the slope, but the rate that it's changing is $3.50 an hour. So up here, we have community theater. They performed a play each Saturday evening for 10 consecutive weeks. Consecutive means in a row. The graph shows the attendance for the performances in weeks 1, 4, 6, and 10. They want the rates of change with attendance. So we're going to look from week 1 to week 4. So week 1, this is starting to irritate Mrs. Kepler, to week 4. We will go 232 minus 124. There's the change in the attendance over 4 minus 1. And that is the change in the weeks. So when we do this, 232 minus 124 is 108 divided by 4 is 27. So that's 27 people per week. Oh, mercy. And then we'll look from weeks 4 to 6. And we'll take 204 minus 232 over 6 minus 4. That gives us a negative 28 divided by 2, which is a negative 14 people per week. So the attendance is actually going down. And then we'll look from week 6 to 10. So week 6 to 10, I'm going to have 72 minus 204 and 10 minus 6. It gives me a negative 132 over 4. So we get negative 33 people per week. Now this isn't saying that you have negative 33 people show up. This is showing the rate of change. So here, from week 1 to week 4, you're gaining an average of 27 people per week for those couple weeks, for those 3 weeks. Then from weeks 4 to 6, you're losing an average of 14 people per week. So 14 fewer people per week are showing up. And then from week 6 to 10, you're losing an average of 33 people per week. So describe the rates and change, and that's what we just did. Okay, the last type of problem is a little different. This time they're going to give you the slope and they want one of the missing coordinates. So they're telling you that this point, 5, 4, is on a line, and the point negative 5y is on the same line, and that line has a slope of 3/5. So we're going to set this up where we have slope, rise over run, equals, I'm going to take my y, I'm just really going to call that y2, minus 4 over my x2 minus x1. And so I'm going to clean it up a little bit. 3 over 5 equals y minus 4 over negative 5 minus 5 is negative 10. This takes us back to the last chapter where we did cross products. This is one of the reasons we did it. 3 times negative 10 is negative 30. And this gives me 5 right here times the quantity y minus 4. I'm going to take the shortcut of dividing both sides by 5 because negative 30 is divisible by 5. Let's go ahead and put it up here. So I get a negative 6 equals, it unlocks the y minus 4. Well, now I just have to add 4 to both sides. So negative 2 is equal to y. So that other coordinate is negative 5, negative 2. All right, this concludes the notes, and they will be put on YouTube. Well, obviously you know that because you're watching them. We'll discuss